So, good evening, everyone. This is lecture number 6 in motion in 1D. And in this lecture, we are going to wind up this topic as well. The only thing that is left is graphs, and we will be discussing those graphs in general. Let us just rewind and see what we had done in the previous class. In the previous class, we had discussed motion under gravity, and we had seen that whatever be the case, we have to use the same equations. The only thing is acceleration is what we know, and it is always equal to g in the downward direction. We had also made some little shortcuts for the maximum height and how much time it will take to come down, and what is the time of flight, and what is u in terms of h. And I have told you that if you can remember all these things, you can solve the questions quite quickly. Yes or no? Remember this? Raise hands will give me more confidence that we understand this. We remember this. We had done a lot of problems, and I told you to try some problems on your own. I think you would have tried it. Yes or no? Simple problems that would have helped us a lot. Now let us not waste any more time. I see that everyone joining back. So let us now move on to today's discussion, and today's discussion will be on graphs. And what I feel is that you might get a question on graph. There's a very high probability of getting a question on graphs in motion in 1D. So this is probably what is going to make or break your question from this particular chapter. So let us begin. There are different types of graphs that can be drawn, and there could be a question on any of these graphs. Acceleration time graph is one graph where you might not get a question, but the probability of getting a question from any of these three graphs is quite high. What is the first type of graph that we are going to discuss? Yes. What is the first type of graph that we are going to discuss? Anyone tell me? The first graph. The first graph for motion in 1D. What is the first graph that we are going to discuss? Yes. I know that you know it. Tell me. Speak up. Uniform motion, Anjali says. Anjali, I'm asking you, which graph are we talking about? Uniform motion is a type of motion. Graph. When you have a graph, you have a x-axis, you have a y-axis, and you call the graph by x-axis, by y-axis and x-axis. I hope you know it. Yes or no? Everyone knows that a graph has y-axis and a x-axis. Yes or no? Do we know this? Yes. We know this, yes? Yes or no? A graph has an axis, an x-axis or a y-axis. And then we draw the graph. Oops, I can't draw a good graph here. Let me try it again. Yes. Now every graph has at least two axes. One is the x-axis, the other one is the y-axis. Whenever we are talking about graphs, we are talking about x-axis and the y-axis. Here, this x-axis is known as the independent variable. I hope you know this. This x-axis is known as the independent variable. Independent variable means we can give it any value that we think is good. So one is the independent variable, and this y is known as the dependent variable. Do we know this? Yes or no? This y is known as the dependent variable. Do we know this? Raise hands will give me more confidence that we know this. Independent variable and dependent variable. What do you mean by independent variable and dependent variable? It is very simple. We can give x any value that we feel like, and then depending on the value of x, the value of y is determined. For example, if I say y is 2x plus 3, and if I ask you to draw the graph of this, how will you draw? Here y is given as a function of x, yes or no? Here y is given as a function of x. This x, the yellow x, this x is your independent variable. You can give it any value that you feel like. For example, I can put the value of x as 0. If x is 0, you put the value of x as 0, you will get the value of y. Y, I think, would be 3. Yes or no? We understand this? Independent variable, dependent variable, do we understand this? How I am calling one as independent variable and one as dependent variable? Shruti, Shrihit, Karthik, Kaushik, Anjali, we're all there. X is in the independent variable. I can give it any value that I feel like. Then depending on the value of x, you will get this y ka value, the green value. That is known as the dependent variable. The dependent variable is always drawn on the y-axis. That is how we assume it. And the independent variable, my dear friends, is drawn on the x-axis. Do we understand this? X-axis is the independent variable. Y-axis is the dependent variable. Now, when we name a graph, now this graph, the graph is always named like this, y-x graph. This graph is known as the y-x graph. That means the independent variable is named after the dependent variable. So we first call the dependent variable and then we call the independent variable. For example, if I plot speed here and if I plot time here, then this graph will be known as what? Anjali, Kaushik, Karthik, Shruti, what will be the name of this graph if I draw speed on the y-axis and time on the x-axis? What will be the name of this graph? What will I call this graph then? What will I call this? S versus T? Yes, it will be speed time graph or speed versus time graph. That is how we name graphs. Is it clear to everyone? Independent, dependent, and how we name it. I hope you have understood this. If you have understood this, then we can move on to the first type of graph that we are going to do for this motion in 1D. Now, if I may repeat my question, what is the first graph that we are going to do, my dear friends? What is the first graph? The simplest of these graphs. What is the first graph that we are going to do? What is the first graph that we are going to do? What is the first graph that we are going to do? Yes? Anyone? The first graph that we are going to do will be known as on y-axis I am going to plot t and on x-axis I am going to plot r. R is the position. So this graph will be known as time is plotted here on the y-axis and the position of the particle is plotted on the x-axis. So this will be known as what? Position of the particle will be plotted on the y-axis and time will be plotted on the x-axis. Therefore, this graph will be known as what? It will be known as position time graph. This will be known as the position time graph. Position time graph of any particle. How will it look like? The position time graph of the particle. How will it look like? Well, I can draw a number of different types of graphs here. Let us look at the most simple variation. I have a position time graph and it looks like a straight line. It looks like a straight line which is parallel to time axis. If this is the graph, what does this graph, if I call this graph as graph number A, the red graph, what does this graph number A, the red graph represent? What type of motion is graph number A representing? Graph is parallel to time axis. Position time graph and it is parallel to time axis. What type of graph, what type of motion is this representing? What is it showing you? What do you understand by this? A graph. What do you think the motion is like? The position of the particle is not changing. It is same. It is fixed. Can you tell me what type of motion this particle is having? Yes. Shruti says uniform motion. What do you mean by uniform motion, Shruti? Is the particle moving? Is the particle at rest? Is it moving with uniform velocity? Is it moving with uniform speed? What do you mean by uniform motion when you say uniform motion? I have never used the term uniform motion. I have said uniform velocity, uniform speed, uniform acceleration. I have not ever used the term uniform motion. Yes. Can anyone tell me what type of motion is this graph representing? Position time graph is parallel to x-axis, parallel to t-axis. Yes. You don't understand this? Okay. So what does this represent? The position of the particle is same. Position is not changing. Do we understand this? The position of the particle is not changing. Do we understand this point? Yes or no? Position of the particle is not changing. Do we understand this? Can I have raised hands from everyone? If the position of the particle is not changing, this graph represents the particle is at rest. Do we understand this? This graph represents the particle is at rest. Now, when the particle is at rest, you can say that the velocity of the particle is zero. It remains constant. So you can also call this graph as a graph with uniform velocity, but that will not be very correct because it does not have any velocity. So it is a graph where velocity is zero. Do we understand this? Yes or no? Yes or no? Do we understand this? This is graph number A. Now, I hope you know what do you mean by slope of the graph. Yes or no? I hope everyone understands the slope of the graph. Do we understand slope of the graph? What do you mean by slope of the graph? If I go back to the previous diagram and if I draw a straight line graph like this, just to keep things simple, if I draw a straight line graph like this straight line graph will make some angle with the x-axis. Do we understand this? Yes or no? This straight line graph will make some angle with the x-axis, which tells us how inclined this graph is, whether this graph is flat or this graph is erect, how much inclined it is with the x-axis. If I find the value of this tan theta, tan of this theta, that is known as m, and that is known as the slope of this graph. Do we understand this? Yes or no? And how do I find the slope of this graph, bacha? It is very simple. I find this coordinate. Let me call this as x1. I find this coordinate. Let me call this as x2. I find this coordinate. Let me call this as y1. I find this coordinate. Let me call this as y2. Can anyone tell me how do I get the value of this tan theta, which is the slope of the graph? I've given you all the values here. How will I find it? Anyone? Slope of this graph. Yes, beta. No one knows? Slope of a straight line, beta? Please tell me. Anjali, Kaushik, Karthik, Shruti, Shrihit. What is the slope of this graph? How will I find the slope of this graph, beta? You know it? Please raise your thumbs. You know it or not? Do I have an answer? Yes, I have an answer from Shruti. That is correct. How do I find the value of tan theta? Tan theta is very simple. I have to find out the value of this perpendicular side, which is y2 minus y1. I have to find the length of this base, which is x2 minus x1. I just divide perpendicular by base, and that gives me the value of tan theta, y2 minus y1 divided by x2 minus x1. Do we understand this? Yes or no? Y2 minus y1 divided by x2 minus x1. I can also write it as delta y, change in the value of y divided by delta x. Do we understand this? Delta means change, change means final minus initial, y2 minus y1 divided by x2 minus x1. Do we understand this? Yes or no? Do we understand this? Yes or no? Raise hands will give me more confidence that we understand this. Y2 minus y1 upon x2 minus x1 delta y by delta x. Now also remember one important point about this. Slope of a straight line is always constant. Do we know this? Yes or no, bacha? Slope of a straight line, whenever you have a straight line graph, the slope of a straight line graph is always constant. Raise hands will give me more confidence. Keep on raising hands so that I can move further ahead in life. I'm not getting raise hands. Everyone? Okay. Now, this graph can have a positive slope or this graph can have a negative slope. Can anyone tell me what do you mean by positive slope? Can anyone tell me what do you mean by a negative slope? What do you mean by a positive slope graph and what do you mean by a negative slope graph? Yes, my dear friends. Positive slope. What do you mean by a positive slope graph? What do you mean by a negative slope graph? Shruti, Anjali, Kaushik, Karthik, Shrihit. Positive slope, negative slope. What do you mean by this? Very simple things. Not very complicated. Positive slope. What do you mean by positive slope? Yes, bacha. Positive slope graph. Positive slope graph means negative x-axis. I don't understand what you mean by that, beta. Positive slope graph means moves from right to left. Not exactly correct. Positive slope graph means you are on the same track. You probably understand this, but you are not able to speak in the light language. Positive slope graph means when the value of x increases, then the value of y also increases, or when the value of x decreases, the value of y also decreases. Do we understand this? If you understand positive slope graph, the line rises. Okay, Shruti, that is correct. The line rises. The line rises means both of the axes do same. Yes, that is correct. That means if x increases, Shruti, Kaushik, everyone, if x increases, y increases. If x decreases, y decreases. Such graph is known as a positive slope graph. If I see this graph which I am now going to paint in blue, is it a positive slope graph or is it a negative slope graph? The graph here, is this a positive slope graph or is it a negative slope graph? The graph that I have drawn. The graph that I have drawn. Is it a positive slope graph or is it a negative slope graph? I wait for your answers. Is it a positive slope graph or is it a negative slope graph? It is a positive slope graph. That is correct. Now, if you have understood what is a positive slope graph, then you have definitely understood what is a negative slope graph. The green line. The negative slope graph means if x increases, then y has to decrease, or if x decreases, y has to increase. That graph is known as a negative slope graph. Do we understand this? Yes or no? No, yes. A negative slope graph is a graph where when x increases, y decreases. If x decreases, y increases. And if I may draw, on the same graph, I don't want to waste time. If I draw it on the same graph, the green one, I hope you can see this green line. This green line, as you can see, is a decreasing slope. Its x is increasing, y is decreasing. So this graph is a graph with negative slope. Do we understand this? The blue one is a graph with positive slope, whereas the green one is a graph with negative slope. Raise hands will give me more confidence that we are there. Everyone? Positive slope graph, negative slope graph. There's also one more type of graph which is known as a zero slope graph. Can you tell me how will a zero slope graph look like? Can you tell me how will a zero slope graph look like? A graph with zero slope. A graph with zero slope means it is a flat line, a line which is parallel to x-axis. And this is the graph that I am showing to you here, the red graph. The slope is 0 for this graph. Do we understand this? The slope of this graph, this is a flat line parallel to x-axis. The slope of this graph is 0. Do we understand this? Yes or no? No, yes. Raise hands will give me more confidence that we are on the same track. Everyone. So you understood, please raise your hands. Kaushik, Karthik, Shruti, Shreet. Anyone is there? Okay, the slope is 0. Now, about this position time graph, we have to understand one important thing. The slope of RT graph, RT means position time graph. Slope of position time graph gives us what? Slope of position time graph, RT graph. Slope of RT graph. Yes, my dear friends, I'm waiting for your answers. What does the slope of RT graph, position time graph gives us? Slope of position time graph gives us. Anjali says displacement. No, that is not correct. What does the slope of position time graph? In some books, it is written as displacement time graph. What does the slope of position time graph is the correct nomenclature? What does the slope of position time graph give us? Or as the book say, displacement time graph. What does the slope of position time graph give us? Yes. No one with an answer. It gives us velocity. That is absolutely correct. The slope of position time graph will give us velocity. The slope of position time graph will give us velocity. Do we understand this? Yes or no? No, yes. Do we understand this? Raise hands will give me more confidence so that I can move ahead with this discussion. Slope of position time graph will give us velocity. Now, If this graph is a straight line graph, SL means straight line, position time graph is a straight line graph, position time graph is a straight line graph, that means the velocity will be uniform or constant. Do we understand this? Because its slope will not change. Slope of position time graph will give us velocity, and if it is a straight line, in this particular graph that I have drawn, it is a straight line, but the slope is 0, therefore velocity is 0. If it is a straight line, the velocity will be constant. Do we understand this? Yes or no? Raise hands will give me more confidence that I am on the same track. Now, this velocity, I can get the average velocity, dabba wala velocity, or I can get instantaneous velocity. Now, how will I get the average velocity? If I find the slope between 2 points, if I find the slope between 2 points, remember average velocity is between 2 points, 2 times here and there, this time and that time. If I find the slope of this graph between 2 points, that will give me average velocity. Then how will I get the instantaneous velocity? Then how do I get the instantaneous velocity? Now, to get the average velocity, I want to find the slope. So it will be R2 minus R1 divided by T2 minus T1. R2 is the final position, R1 is the initial position, T2 is the final time, T1 is the initial time. I can write it as delta R by delta T. Everyone understand this? Yes or no? No, yes. It could be a xt graph. So x2 minus x1 divided by t2 minus t1. It could be a yt graph. If the particle is moving along y-axis, y2 minus y1 upon t2 minus t1. Do we understand this? Yes or no? No, yes. So if I find the slope of this graph between 2 points, that will give me the average velocity. Raise hands will give me more confidence. Do we understand this, my dear friends? Say, for example, in case of this question, we had found out the slope of the graph was y2 minus y1 divided by x2 minus x1. That was the average velocity between x1 and x2. That was the average velocity between x1 and x2. Do we understand this? Do we understand this? Yes, that is correct. Do we understand this, everyone? If I find out the slope between 2 points, that will give me average velocity. And I ask you, how will I find the instantaneous velocity? If I find the slope at any point, if I find the slope at any point, if I find the slope at any point, that gives me the value of instantaneous velocity. As Shruti says, this is the slope of the tangent line. If at any point I draw a tangent, the slope of that tangent will give me the instantaneous velocity at that point, or I can find it as dr vector by dt. Do we understand this? Yes or no? No, yes. These are also vectors. Do we understand this? Yes or no? No, yes. Instantaneous velocity, to find out the instantaneous velocity, you have to find the slope at given point. To find average velocity, you have to find the slope between 2 points. If the velocity is uniform, if the velocity is uniform, if the velocity is uniform, average velocity and instantaneous velocity will be same. Do we understand this? If the velocity is uniform, then your average velocity between 2 points will be equal to instantaneous velocity. Do we understand this? Yes or no? No, yes. Raise hands will give me more confidence. So that was about the red graph. The red graph was parallel to time axis. It was representing a particle moving with uniform velocity, but that velocity was zero. Therefore, the particle was at rest. Do we understand this? Yes or no? No or yes? Raise hand will give me more confidence and help me in moving further ahead in life. Shall I move further ahead in life? Now, if I draw a graph which is like this, graph B. This graph B is parallel to y-axis. So what is this graph showing us? Why time is not changing, but the position of the particle is changing. This is a graph with infinite or not possible slope. This graph has an infinite slope, which is not possible. So such type of graph, you can always draw it, but practically this graph is not possible because at one time the particle cannot be at different positions. Here in this graph, at one time, sometimes the particle is here, then at the same time it is here, then at the same time it is here. So it is becoming omnipotent and omnipresent, which we think right now is not possible. So this is a graph with infinite slope or not possible or undefined slope. This type of graph is not possible. Do we understand this? Yes or no? No or yes? So we have seen one graph of zero slope, which is definitely possible if the particle is not moving. We have seen one graph of infinite slope, which is definitely not possible because at one time the particle cannot be present everywhere. Yes or no? No or yes? Do we understand this? Please raise your hand so that I am in no doubt that you have understood this. Okay, that takes me to graph number C. Graph number C. Or let me not draw it by red. Draw it by the next color. And I can use green color. Let me move on to graph C. Oops, why color of this thing has changed? Okay, stranger things have happened. Okay. Now, if I draw a graph like this, let me draw it with the black pen. And this is the graph that I have drawn. I've drawn it with a black pen. Now, what does this graph represent? Again, this is a graph drawn between t, time, and r, position, time graph. What does this represent? This represents the angle is theta, yes or no? This represents a motion with uniform velocity, yes or no? Do we understand this? This represents a motion with uniform velocity. Do we understand this? Slope is positive, therefore the velocity is positive. Do we understand this graph? Slope is positive, velocity is positive, and this is motion with uniform velocity. Do we understand this? Yes or no? No, yes. I hope everyone is drawing this. Everyone is drawing this. Yes or no? No, yes. Now, if I draw another graph, graph D is again a straight line graph. So this is again motion with uniform velocity. Motion with uniform velocity, but here the slope of the graph is negative, and therefore the velocity is negative. Do we understand this? Yes or no? No, yes. Raise hands will give me more confidence. that we are on the same track. Okay, I'll give you 2 minutes to note this down. I hope everyone is noting it down. 2 minutes. And then I will present a question for you. Is everyone ready? Anyone ready for the question? Yes or no? Certainly. Something is wrong. Okay. Can I present a question for you now? Question number 1 on the graph. Yes, here comes this question. Now, remember, whenever someone uses the term uniform motion, this term uniform motion means motion with uniform velocity. Remember that. Someone uses the term uniform motion, it represents a motion with uniform velocity. Now, which of the following graphs represent uniform motion? A motion with uniform velocity, or I can say constant velocity. Yes, my dear friends. Yes, my dear friends. Can I have your answers, please? Yes, bacha. Anyone with an answer? Yes, bacha. Which of the graphs represents uniform motion? And the answer is only one student has given me the answer. What about the others? Anjali, Kaushik, Karthik, Shruti. Which option is correct? Uniform motion means motion with uniform velocity, my dear friends. Which is the correct option? No one knows it. Anjali, what is your answer? Kaushik, what is your answer? Shruti has given me the answer. And the correct answer is answer A. Uniform velocity, this is the answer. You may also argue, sir, why is C wrong answer? C is also uniform velocity, but here, my dear friends, as I have said, velocity is 0. So basically, I will call this motion as motion at rest, and therefore it probably will not be prudent to say, I mean, if someone is moving at if someone is moving with uniform velocity, or someone is at rest, both the motions are same. But if a question comes in the examination hall where these two graphs are given and you are asked which is the graph which represents uniform motion, the correct option that you have to mark is A. Do we understand this? Even though C is also correct. So if it's a multiple choice question, then answer is A and C. Do we understand this? Yes or no? Do we understand this? Can I have raise hands from everyone that we understand this? Okay, can I move on to the next question? Please don't note the questions completely. Just look at the question and give me the answer. Because if you note down the entire question, it will take a lot of time and we don't have time. This is the next question. And let us see who gives me the answer for this one. Which of the following displacement time graph? It may not be displacement time graph, it may be position time graph. From the following displacement time graph, remember how they have written the name and how they have drawn the diagram. So please keep an eye on that and see how it is there. Okay, from the given graph, what is the velocity of the body? And I'll give you 2 minutes to solve this. Yes, my dear friends. Which is the correct answer? Option A. Anjali says option A. Well done, Anjali. What about the others? What about the others? Do we all think that it is option A? Kaushik says option C. So there is a fight between option A, which is pink, and option C, which is yellow. Yes. What about okay? What about the others? Option A, option C. Anjali, do you think it's option A? Tell me. Instantly, you have given me the answer option. Shruti has given me same answer. Option A. That means option A is winning. Democracy. Remember, there is no democracy in physics. Only those answers, only that answer wins, which is the correct answer. That means, Kaushik, you have to explain why your answer is not matching the other two students. Yes, Kaushik, tell me. How did you get root 3 and not 1 by root 3? Yes. Yes, bacha. Can you speak up? Yes, sir. Option C. Now Anjali has taken a U-turn. And the problem is as soon as you see, as soon as you see this 30 degrees and you find out tan of this 30 degrees, the answer becomes 1 by root 3. But remember, this angle is with the displacement or the position wala axis. If I go back, and the reason of doing this question was this thing only. If I go back, now Shruti has also changed the answer. Anyways, if I go back, yes, it's the reverse beta Kaushik. If I go back, remember this angle theta is the angle that it makes with the time axis, not with the displacement or the position axis. And that is the mistake. That is the mistake that you may make. And that is the reason that this question was given. So do not mark your answers in a haste, because if you do it in a haste, then you might land up with wrong answers. And I hope you have understood what was wrong in this answer. Yes or no? No, yes. Okay, that takes me to the next question, and I hope you can solve this question correctly. This would be question number 3. I hope everyone is noting down, not the question. You don't have to note down the question. You can just solve the question. If you can solve the question, do not waste your time in noting down the question. And this is the next one that comes. The displacement time graph of two particles A and B are straight lines inclined at an angle of 30 degrees and 60 degrees with the time axis. What is the ratio of velocity VA is to VB? And I wait patiently for your answers, my dear friends. Remember, once we do one thing, we will lock it down. We will solve all possible problems that can come, and then only we shall move ahead in life. Yes, my dear friends, I wait for your answers patiently, patiently. Anyone with an answer to this question? Option D. Kaushik has given me an answer straight away. Option D. Anyone who thinks otherwise? Yes, my dear friends, I wait. How did you get Kaushik? The answer? Can you tell me? To find out the velocity of A, you have to find the slope of displacement time graph of body A, and it is inclined at an angle of 30 degrees. 30 degrees, so tan of 30 degrees will be the slope. Tan of 30, so tan of 30 will be 1 by root 3. On similar lines, this was yellow, yellow, yellow. On similar lines, you have to find the velocity of the particle B. That would be equal to tan of 60 degrees because it is inclined. The displacement time graph is inclined with the time axis at an angle of 60 degrees. So this is tan of 60 root 3. The rest is pretty simple. Ratio of tan 30 and tan 60. And the answer is what we have got. 1:3. Everyone got this answer? Yes or no? No, yes. Are you getting some confidence? Okay. Comes the next question, my dear friends. And I hope you can do justice to this one as well. Okay, these questions have come previously many times, and I think this is from the sheet that I have sent you. I don't know what you're doing with the sheet, but I thought that I will do the sheet as much as possible in the class only. The displacement versus time graph for a body. This is, I think, example number 32 from your sheet. The displacement versus time graph for a body moving in a straight line. So you can look at the sheet and then you can answer and you can take the answers from there. Which of the following graph represents the motion when no force is acting on the body? Oh, force. We'll not discuss force. Anyway, yes, my dear friends. Which part of the graph is there no slope? Right? Which, there is no force, not slope. There is no force. Yes, my dear friends. What is the correct answer? Here. I have an answer. Shruti has given me an answer. What about the others? Yes, anyone? What is the answer here? Where there is no force. Option B, sir. BC does not have force. Yes, that is correct. And how did you get it? How did you get it? That is correct. Look at the part B to C. The position of the particle does not change. The particle is at rest. Its velocity is zero. Does not move. Its acceleration is zero, which implies that the force acting on the particle is zero. The answer is from B to C. Do we understand this? Yes or no? No, yes. Anyone understands this? Can I have raised hands from everyone in the class? Okay. Can I move on to the next question then? Can you move on to the next question then? Do we understand this, bacha? Everyone? Okay. Then comes the next one. Question number 4 or question number 5, I have forgotten. Oh, I think it's 5. Question number 5. And here it comes. Anyone has any doubts, please ask. Question number 5. A car deaccelerates, as the acceleration spelling is not correct, at a constant rate during a period commencing at t is equal to 0. So car is deaccelerating. Which of the following displacement time graph? It may not be a displacement time graph. It may be a position time graph. So pardon the language. Which of the following displacement time graph represents the displacement of the car? Which of the graph is correct? That is what they are asking. As simple as that. As simple as that. Can you tell me the answer? Can you tell me the answer for this one? Yes, bacha. So look at the graphs. C, deacceleration. It is deaccelerating, constant deacceleration. Okay. Now look at graphs B and graph C. The displacement time graph is a straight line. Yes or no? No, yes. That means the velocity here is constant. Do we understand this? If velocity is constant, my dear friends, then acceleration is zero. Do we understand this? Yes or no? Do we understand this? Yes or no? Raise hands will give me more confidence that we are on the same line. Now look at graph A and D, and let us try to understand the difference between the two graphs. Here velocity is variable. Yes or no? Because graph is not a straight line. Here also the velocity is variable. Graph is not a straight line. Do we understand this? Raise hands will give me more confidence that we are on the same path. Velocities are variable. Now if I look here in this graph, here at this point the slope is zero, velocity is zero. Here velocity is large because the slope is large. The line has become steeper. If I look here at this point origin, velocity is large because the slope is large, and here the graph has become flatter, so velocity is approximately becoming zero. So in one case the velocity, in this case, in one case the velocity is increasing, and in the other case velocity is decreasing. Do we understand this? This thing has gone, I don't know why. Let me try to bring it back. So in one case velocity is increasing, and in the other case velocity is decreasing. Do we understand this? In which case is velocity increasing, and in which case is velocity decreasing? Here if I look, velocity is increasing. Here if I look, velocity is decreasing. So where velocity is decreasing, here we will find that the particle is deaccelerated. Do we understand this? Yes or no? Raise hands will give me more confidence that we understand this. Okay, shall I move on to the next question? So the option which is correct is option D. Do we understand this? Okay. Here comes the next question for you. Which of the following cannot be a distance time graph? Four options are given. Which of them is not possible? Which of the following distance time graph is not possible? Can you tell me the answer? Option B is not possible, sir. Why is option B not possible? Should you tell me? Why is option B not possible? Should you tell me? Why is option B not possible? Yes, that is the correct answer. Option B is not possible. Why is this the correct answer? Because distance cannot decrease, distance cannot decrease. Here, if you look at the slope of this graph, here, if you look at the slope of this graph, slope is negative. Now, slope of position time graph gives you velocity. Slope of distance time graph, yes, will give you speed. Speed cannot be negative, and therefore this graph is wrong. Do we understand this? Yes or no? No, yes. Raise hands will give me more confidence that, sir, we are on the same track. From everyone in the class. Wake up, wake up, wake up, Sid. Anyone is woken up, Sid? Here comes the next question. This graph shows the displacement time graph for a particle moving in a straight line. The average velocity for the time interval 0 to 5 seconds is 0 to 5 seconds, my dear friends. Just my dear friends. What is the answer for this one? The average velocity for the interval 0 to 5. Remember, they have used this term displacement time graph. It could be a displacement time graph. Rather than being a displacement time graph, it could also be a position time graph. Previously, they used to use displacement time graph, but the correct thing is position time graph. How do I get the average velocity? Anyone? How do I get the average velocity? Yes. Anyone with an answer? Do I have some answers here? No, I don't have any answers up till now. C, -2. That is correct. How did you get Anjali? That is correct. Average velocity. Average velocity is total displacement delta r divided by total time. Yes, slope between these 2 points. So what do? I draw a straight line from here to here and I find out the slope of this straight line. The slope is going to be negative. The slope is going to be this distance divided by this distance. That is total displacement, final position, which is -10 divided by initial position, which is 0, -10 divided by 5 is equal to -2 meter per second. So you could draw a straight line and find out its slope, or could draw a straight line and find out its slope, this distance y divided by x, or you can do it by total displacement divided by total time. No matter how you do it, you will end up with the same answer. Do we understand this? Everyone in the class, do we understand this? Anjali, Shruti, Kaushik, Shrihit, are we there on the same page? Yes or no? No or yes? I hope we are getting more and more confident as we are going ahead. And this is the last question on this position time graph. Here it comes. The book may say displacement time graph, but don't worry, displacement time graph or position time graph is the same thing. Shows the position time graph. What is the ratio of speed in the first and the next 2 seconds? So what is the speed in the first second? The ratio to the speed in the next 2 seconds, and your time starts now. I'll give you 2 minutes. Yes, my dear friends, do we have an answer? Ratio of speed in the first second to the ratio of speed in the next 2 seconds. In the first 1 second, the speed is constant. In the next 2 seconds, the speed is constant. Or I should say velocity is also constant because it is a straight line. Displacement time graph, position time graph is a straight line. Yes, I'm waiting for your answers, my dear friends. I wait for your answers patiently. Yes. Who's going to give me the answer? Yes. No one? Well, then I will tell you the answer, how to solve it. In the first 2 seconds, I can find out the average velocity. It is moving in a straight line. Average velocity will be equal to instantaneous velocity. That will be equal to average speed, the magnitude of that. That will be equal to instantaneous speed. So I have to find the slope of this straight line. Yes or no? Yes. And remember, we are talking about speed. Speed is never negative. Velocity can be negative depending on the direction. So first off, I find the average speed, S average, average speed. Average speed is the slope of this graph in the positive sense. So this is the perpendicular is 30 divided by time is 1. So it becomes 30 meter per second. That is the speed in the 0 to 1 seconds. If I find out the average speed from 1 to 3 seconds, the perpendicular is 30 divided by time is 2. So I'll get 15 meter per second. If they would have said average velocity, then this would have been negative because the slope is negative, but speed is never negative. You can find out the ratio and the ratio will be 2:1. Do we understand this? Yes or no? No, yes. Okay. Then I think we have done enough problems on position time graph. This is the time to move ahead. I'll give you a minute to note this down, and if you have any doubts, please ask. To move with the next graph, the next graph would be, and the next graph would be velocity time graph, VT graph. Do we understand this VT graph? So now what is going to happen, my dear friends, is we will have velocity plotted on the y-axis and time plotted on the x-axis. This is VT graph. Do we understand this? Yes or no? No, yes? Well, the first thing that you have to understand is slope of velocity time graph will give us what? Slope of position time graph gave us velocity. Slope of velocity time graph, yes, it will give us acceleration. Well done, my dear friend. Now, if this slope is a straight line, the acceleration would be uniform or constant. Do we understand this? Yes or no? If this graph is a straight line, the acceleration would be uniform or constant. Now I can also find average acceleration from here, and I can also find instantaneous acceleration from here. How will I get average acceleration? If I find it between 2 points, then I will get average acceleration. So I will write it as v2 minus v1 vectorly divided by t2 minus t1, or I can write it as change in velocity delta v divided by delta t. Do we understand this? Yes or no? No, yes. If I find it at any point, I will get the value of instantaneous acceleration. So that will be dv by dt. If the acceleration is constant, straight line, The graph is a straight line. Then I will have average acceleration same as instantaneous acceleration. Do we understand this? Yes or no? If I have a graph like this, graph A, what can you say about graph A? If I talk about graph A, velocity is constant, yes or no? Slope is 0. Acceleration is 0. Do we understand this? Yes or no? No, yes. If I have this graph, which is like this, graph B, this is graph, slope is infinite or not defined. Acceleration is infinity. This graph is not possible. Do we understand this? Yes or no? No, yes. If I have, and I'm drawing all the graphs in the same line, if I have this green graph, graph C, velocity is variable, slope is constant, slope is positive, time is increasing, velocity is increasing, therefore acceleration is constant and positive. Do we understand this? Yes or no? No, yes. Raise hands will give me more confidence that we are on the same track. The last but not the least, if I draw a graph like this, I call it graph D. Velocity is variable, slope is negative and constant, acceleration is negative and constant. Do we understand this? Yes or no? No, yes. That is the first thing that we must remember about a velocity time graph. The slope of velocity time graph will give us acceleration. It can give us variable, it can give us average acceleration between 2 points, or it can give us instantaneous acceleration at a one point. 4 types of acceleration I have drawn. If the graph is a straight line parallel to t-axis, acceleration is 0. If it's parallel to y-axis, it is not possible. If it is like this, acceleration is positive. If it is like this, acceleration is negative. Do we understand this? Yes or no? No, yes. What other thing can we calculate from a position from a velocity time graph? Point number 2, what can we calculate from a position time graph, from a velocity time graph? Remember, from a position time graph, we could only calculate the velocity from the position time graph and the position. Here, from the slope, we can calculate the acceleration. We can also find out the area. Point number 2, the area of VT graph. What does area of VT graph gives me? Yes, my dear friend, area of VT graph. From the area of VT graph, you can find out, displacement as well as distance. Do we know this? Yes or no? No, yes. Do we know this? No, yes. Okay, now how do we find out displacement and how do we find out distance? In all the three cases, we will find area number 1, area number 2, and area number 3. Area number 1, area number 2, area number 3. Area number 1 and area number 3 are above time axis. Area number 2 is below time axis. To calculate distance, distance is always positive. We will add all the three areas, taking all of them as positive. Area 1 is positive, area 2 is positive, and area 3 is positive. But to find out displacement, area 1 and area 3 will be positive, but area number 2, which is below the time axis, will be taken as negative. You can easily find the area. You will have geometrical figures: triangle, half base into height, rectangle, length into breadth. If you have a trapezium, can use the area of the trapezium, half into sum of parallel sides into the distance between the parallel sides, or you can break that trapezium into a triangle and a rectangle, and then you can find out the area. Do we understand this? Yes or no? No or yes? You can find out the area of the displacement time, velocity time graph. That will give you the distance as well as the difference. Can I have some reason that we understand this? Yes or no? No or yes? Can I straight away give you a question, my dear friend? I hope everyone has noted this down. Yes or no? No or yes? Okay, that makes my job easier. And now I can ask you, now I can ask you a question. Yes or no? Can I ask you a question? Yes or no? Everyone is ready? Here comes the first question. In the following graph, they've only asked you to find out the distance, but let me ask you all the questions that are possible. Okay, let us first find out the distance and also find out the displacement. Will there be any change in distance and displacement, or will the magnitude of displacement and distance come same? It is very evident that this entire graph is on the positive side of the positive side of y-axis, above time axis. So in all these cases, distance and the magnitude of displacement would be same. Yes or no? No, yes. So can you tell me the displacement or the distance traveled? Just have to find out the area. Yes, my dear friends. Option A, sir. You just have to find out the area, and I think you would have done a good job in finding out the area. You find out the area of the three triangles that are given to you. You find out the area of this triangle, half base into height, half into 15 into 10. Then you find out the area of this rectangle, length into breadth. 10 into 15. Then you find out the area of this triangle, half into base into height, the three triangles, triangle number 1, rectangle number 2, and triangle number 3. Or you can straight away use the formula for trapezium, half into sum of parallel side into the distance between the parallel side. Yes or no? Everyone got this answer? Can I have raise hands from everyone? Anjali, Kaushik, Shruti, Shrihit, do we get this? Shrihit, Shruti. Well done. Then one more question and then we'll move on to the last graph and then we will solve the remaining question. Last graph, you'll hardly find any questions. Anyways, for a certain body, the velocity time graph is shown in the figure. The ratio of applied forces for the interval AB from A to B and from B to C. What is the ratio of the forces? Ratio of the forces they are asking you. How will you find out the ratio of the forces, my dear friends? Remember, slope of velocity time graph gives us acceleration. Multiply force to multiply acceleration by mass, you get the force. That is how things are done. Yes, my dear friends. Can I have your answer for this one, please? Anyone? I patiently wait for your answers. Yes? No one? Shall I solve it for you? In this case, and in this case, you have to just find out the slope of this line. Yes or no? The slope is constant, so acceleration is constant. You can find out instantaneous acceleration or average acceleration. So I can find out the average acceleration from A to B. And average acceleration from A to B will be tan of 30 degree with a positive sign. So it will be 1 by root 3. Do you all agree on this? Raise hands will give me more confidence that we all agree on this. Then we find out the average acceleration from B to C. That will be negative because the slope is negative. Negative tan of 60 minus root 3. And we then simply take the ratios of the average acceleration. Average acceleration multiplied by mass will be force, average force, average acceleration is constant, so force is constant. M and M will get cancelled, and you have the ratio of applied forces will be 1 by root 3 divided by minus root 3. So minus 1 by 3. Do we understand this? Minus sign indicates that if one force is like this, the other force is like this. Do we understand this? Yes or no? No, yes. Everyone has noted this down? Yes or no? Can I move on to the next part? Anyone understands this? Shruti, Kaushik, Anjali, Shreet. Can you move on? Well, the last graph is acceleration time graph. You hardly see any questions on this, so I'll just give you a single simple question. That is all that we need. Acceleration time graph. No one asks acceleration time graph anymore, but it is my humble duty that I give this graph for you. So how is this graph? Oops. Let me make it. So I will have t plotted on the x-axis and acceleration plotted on the y-axis. AT graph, acceleration time graph. Now, the first thing that you have to understand is slope of AT graph. No one is going to ask you this. Slope of AT graph gives you something known as jerk. Now, this jerk is out of your course, which is the rate of change of acceleration with time. It is known as jerk. When you're sitting in a bus and the bus is at rest and the bus starts, you get a jerk because bus suddenly accelerates. Its velocity changes with time. Its acceleration also changes with time. The slope of AT graph is known as jerk. No one is going to ask you jerk. So slope of AT graph is out of the question. What is in interest is area of AT graph or area under AT graph. Now remember, area under AT graph gives change in velocity. Remember, not the velocity, it gives change in velocity. That means it gives us delta V or it gives us V2 minus V1. Do we understand this? So if I have a graph like this, if I have a AT graph, and in most cases you will have a AT graph as a straight line. If you have a graph like this at time t1 and at time t2, as you can see, the acceleration is a. So this is a graph with constant acceleration. Do we understand this? This is a graph with constant acceleration. The area under this graph, which is this area, you can easily find out this area length into breadth. Now, if I say, my dear friends, that velocity here is v1 and velocity here is v2, final velocity is v2, initial velocity is v1, then my dear friends, v2 minus v1 will be equal to a into t2 minus t1. Do we understand this? Yes or no? No, yes. A into t2 minus t1 is the area under this graph, and that will be equal to, my dear friends, change in velocity. Do we understand this? Yes or no? No, yes. Everyone has understood this. Everyone has noted this down because you might not find it in your notes or your books. Please note it down. I'll give you a minute to note it down and then I'll present a question for you. Have you all noted this down, my dear friends? Yes or no? No, yes. Raise hands will give me more confidence. Shruti, Anjali, Kaushik, Shay. Are you ready for the question? Are you ready? And let's go for it. This is a question based on an acceleration time graph. Acceleration is plotted on the y-axis. No surprises there. Time is plotted on the x-axis. No surprises there. One surprise here is it has become anda. It cannot be an anda. It has to be 2. So this is a body not moving with a constant acceleration but with a variable acceleration. This is 0 seconds. As you can see, velocity at 0 seconds is let us say plus 5 meter per second square, plus 5 meter per second. Then the body gets accelerated, and acceleration is not uniform, it is variable. You have to find the velocity at 5 seconds. Can you do that for me? How many of you think that you can do this for me? Raise hands and let me know. How many of you think that you can solve this question, my dear friends? Kaushik certainly believes that he can, and I certainly believe that all of you can. If you understand the basic things, simple things that we have done, I am sure that you would be able to crack this one easily. I'll give you a minute to do it. Yes, my dear friends. Do we have anything that looks like an answer? Sounds like an answer. Yes. I wait patiently. Anyone would surprise me with my answer? Yes. No one? 2a. 2a. What is a? Acceleration. The value of acceleration is given. Why is the answer 2a, my dear friend? Kaushik? I don't understand what you mean by 2a. I'm sorry. 2a. Interesting answer. 2a. Anyone else? Shall I solve it for you? Yes or no? No, yes? No one? Okay. The first thing you got to do is to find out area under this graph. This area. I guess all of you can find it out. Yes or no? This is half into base into height. Do we understand this? half into 5 into 2. So this area is 5. Yes or no? Yes or no, my dear friends? Do you understand this? Yes or no? The area under this graph gives me change in velocity. So change in velocity is 5. Change means final velocity, velocity at 5 seconds. This is my final point, bacha. Do we understand this? Velocity at 5, final point. Minus initial velocity is velocity at 0 seconds, my dear friends. That is equal to 5. So velocity at 5 seconds is 5 plus velocity at 0. And my answer is 10 meter per second. That is the answer, my dear friends, that I was looking for. Do we get this? Yes or no? No, yes. Do we understand how I have done this? The area under velocity time, the area under acceleration time graph gives us change in velocity. Do we understand this now? Can I have raised hands from everyone in the class that we understand this, sir? Okay. Then let us move on to a different question. Has everyone noted down this question? Can I move ahead in life? Please raise your hands so that I can move ahead with the next question. Yes or no? This is a yes. Kaushik says wait. Kaushik, do you want me to wait? Oh, this is a yes. This is a yes. Go ahead, sir. This is wait, sir. Go ahead, sirs. And this is the question, sir. Let us see who gives me the answer, sir. The adjoining curve represents the velocity time graph. Most of the question that you're going to have in this graph would be probably velocity time graph, because there you can also calculate the acceleration. There you can also calculate the displacement or the distance. The adjoining curve shows the velocity time graph of a particle. Its acceleration values along OA from O to A, 0 to 10 seconds, OB, AB from 10 to 20 seconds, and from 20 to 40 seconds, B to C is respectively. And you have your options. I'll wait for 2 minutes and then I'll come back. Do we have an answer here, my dear friends? The adjoining curve represents the velocity time graph of a particle. Its acceleration along OA, AB, and BCR. Kaushik has given me an answer, but I think he has said option C. Option C. C, 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 C. No, 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 no. Option C is not correct, my dear friend. Anyone with an answer? From A to B, it is very clear. From A to B, it is very clear. Velocity is constant. Acceleration is zero. Yes or no? No, yes. Do we understand this? Yes, Kaushik. Now you are correct. So from A to B, acceleration is zero. So this option is ruled out. Now you check the acceleration from blue path from O to A. So it will be this length, which is 10 divided by this breadth, which is 10. 10 divided by 10 is 1. All the option have 1. This option and this option has already gone. So only correct options are A and B. In A and B also, both the options are matching. The only thing is here it is negative and here it is positive. So you just have to find out whether the acceleration in the part B to C is positive or negative. You don't have to even calculate that. You can easily see that this is negative and therefore the correct option has to be option A, my dear friend. Do we understand this? Yes or no? No, yes. Anyone understand this? Yes or no? No, yes. I need great signs from everyone in the class, my dear friends. So the correct option is option A. That takes us to probably the last question for this class. And I hope we have done enough questions that will give you enough confidence to solve any question. You have that exercise, that sheet with you. Today is Saturday, so tomorrow you probably don't have any class as such. Think you can do enough practice in the day that you have. And this is the question, the finale coming up. This question has come in JEE Main and JEE Advanced many times. Which of the following graphs represents the velocity? Sometimes it is for velocity, sometimes it is for speed. Which of the following graphs represents the velocity of a steel ball which falls from a height onto a marble floor? V represents the velocity of the particle and T is the time. I've dropped the ball, dumb, on a marble floor. Will rebound back. Which graph represents VT graph correctly of this falling steel ball on the marble floor? And I'll give you a minute to discuss this, to solve this, and tell me the answer. Yes, I have the answer. And the answer is option A. How do you get option A? Now, when you drop the ball, its velocity is 0. The ball is coming down. So velocity is in the downward direction. It will keep on increasing in the downward direction. This is negative. There is no other velocity in the downward direction. So all these options are wrong. This is only the option which is possible. But here you must see that it is falling under gravity. Its acceleration is constant. Therefore, it has to be a straight line. Then it falls with certain velocity. After falling, it will bounce back. Bounce back means the direction of velocity will be reversed. As you can see now, the direction of velocity has reversed. Will come up. the velocity will decrease. Velocity is decreasing. It will become zero. Then it will come down again, bounce back. The velocity will keep on decreasing until it stops eventually. The only graph which represents this is graph number A, and that is the correct graph. Do we understand this? Yes or no? No, yes. Everyone, raise hands will give me more confidence. If this was a question of speed versus time graph, remember the same graph would have been there, but velocity never becomes negative because, but speed never becomes negative. So the graph never goes on the negative side. It just remains on the positive side. Do we understand this? Yes or no? No or yes? So if this was a question of speed time graph, same graph, but no negative side. It will not go in the negative. It will always remain on the positive side. With this, we come to an end of this particular chapter. I hope everyone is confident with this chapter. Yes or no? The chapter of motion in 1D, we have done almost all types of questions that are possible, starting from simple questions of average speed, average velocity, distance, displacement, average acceleration, instantaneous acceleration. And we moved on to uniform acceleration, non-uniform acceleration. We have seen various types of question. We have seen motion under gravity, motion in a straight line, motion in 1D. The name of the chapter was motion in 1D, but we have solved question of 2D and 3D also. Yes or no? Please raise your hands and let me know that we have solved the question of 2D and 3D as well, even though the name of the chapter was 1D motion, but we will take motion in 2 dimension officially from the next class. So from the next class, we'll move on specifically, leaving this 1 dimensional world, we'll move on to the 2 dimensional world and see what types of questions are there in the 2D world. So take care. Have a nice day. If you have any doubts, you can always ask me. Until the next class, take care. Bye bye.